Hi, I'm Donald McIntyre, Senior Editor at the ETC Cooperative. This is the Ethereum Classic show. And joining us is Isaac Ardis. He's core developer of the Core Geth software client of Ethereum Classic. Hi, Isaac, how are you?
Hi, Donald. Doing well. Thank you.
Thank you very much for your time. And Isaac, I wanted to talk to you today about the Core Geth client to explain it a little bit. But before that, can you tell me about your background and what you do for Ethereum Classic?
Yeah. I've been working with Ethereum Classic since I think about 5 years ago, and I've been working on the client that whole time. The client has shape-shifted over the years. We started with Ethereum Classic had its own fork, and then that has moved around a couple of times since then, but I've been around through it and have really enjoyed getting to grow with the protocol. And
and you also contributed key parts like Myth and other things to the client and the protocol, the ETC version of the EVM protocol, I guess. But did you work also on other tools? For example, there's a website that measures the probability of 51% attacks on ETC. You worked on that as well?
Yeah, I've done, a few different tools.
A few lateral things other than the core client.
Yeah. Yep.
And Core Geth is the Ethereum Classic version, if we could call it that, of Go Ethereum. No, it's like a downstream client of Go Ethereum, which is the Ethereum client.
Yep.
How does that work? So all the innovation and research and development occurs over there, and then we adopt whatever we want to adopt. How does that work?
Yeah, that's the general pattern. For those who are unfamiliar with sort of upstream and downstream ideas in these code and version control systems, we set Core Geth up to be in a downstream position from Go Ethereum, which is the main and dominant client on the Ethereum network. And this is a little different than how we did it back when I first started. At that point, it was also a fork, but it was a fork that was intentionally non-downstreamed. So the code bases diverged and were expected to stay diverged permanently. And so there's pros and cons to both patterns, definitely. When we're not working downstream, then we have we're closer to just maintaining control of the client, basically, and getting to make design decisions and implementation decisions with a high degree of sovereignty, and while working downstream. And so the con of that, though, is that if there are changes that happen at Ethereum and Ethereum Classic wants to implement those too, which Ethereum Classic has historically done by and large. We've adopted EVM and protocol changes pretty much one-to-one with Ethereum. And so when we were doing the divergent fork, it was a lot of developer work that basically boils down to something like reinventing the wheel. Because you need to take you're responsible for your own implementation.
Exactly. It's like replicating the same functionality, but in your own way.
Yeah. And that's just a result of the protocol decisions that the network is making. And so if we make the same decisions as ETC, then the protocol is reinventing the wheel. And so the code needs to do that too. So on the other hand, though, being downstream, which we are now with Core Geth, the perk of that is that we get to pull in those changes for better and worse, because some of the code that is added or modified upstream is potentially irrelevant for us, and that's a downside. But sometimes it's it's very, very pertinent in the case of bug fixes
Yeah.
to the general public. And so that we also get to inherit the fixes as well as the flaws with that too.
Yeah.
And so for us so far, that's made, it's worked for us. And Core Geth's, one of the primary priorities that we have at Core Geth is stability. And that's something that I sort of got drilled into my brain 5 years ago, back when the clients were not stable. And it became really clear to me that having a stable, trustable, reliable client is paramount for these operators.
Yeah.
And so Core Geth in that way is a semi, I would say, like a reluctant downstream. We're happy to take code, but we are slow to do so because we want to make sure that we're not pulling in bugs.
That's very important that you say that, because I've always been in like the abstractions and clouds of the Ethereum Classic philosophy and principles and stuff like that. And hearing that, what you just told me of a core developer directly, because you are hands-on on the protocol and designing, etc., is very good, because it fits very well with the generally conservative philosophy of Ethereum Classic, no?
Yeah, that fits. Yep. And over the years, we've sort of made work for ourselves, or myself, in sort of re-architecting, I guess, seemed like a big fancy word, but at least changing the implementation at our Core Geth fork, because the way that Ethereum Classic approaches the Ethereum protocol is sort of inherently abstracted, especially relative to Ethereum, the Ethereum Foundation network, because we want to look at that protocol as this extensible protocol that that you can take features, leave features, combine them, and Ethereum Classic is fundamentally a configuration change originally, and so for Ethereum Classic, it's important to be able to manage the features that are coming in articulately, and so there have been some changes to the Core Geth code that let us do that a little bit better, and hopefully is able to turn Core Geth. The idea is to make it an extensible client, and an EVM. As long as your chain is running an EVM, we're hoping that Core Geth can support it. So.
And also not necessarily be strictly downstream, but also be upstream of others when there's an innovation on this side. Like that. So let's talk these things, and we're going to get to the EVM concept and also the concept of Core Geth that may work for other blockchains, not only for ETC. So just to go from top down, from the higher level concepts, and then to the details of the specific unique features of Core Geth, I wanted to ask you something very abstract to start, because this interview is to help people who come for the first time to understand what is Core Geth and end up operating a node in their computers, and they may be technical or non-technical users. So let's talk about what is the difference between a network, a blockchain, and a cryptocurrency. First, if you can explain that.
A network is several computers connected by a series of tubes. And blockchain is the data. That's the actual ledger. And information about that ledger is passed around in the network, and part and parcel defines the way that ledger can grow and change. And what is a cryptocurrency? I think it's a ghost.
The cryptocurrency can be said within the data. So you have the network of computers, which are machines that can be called nodes, and they communicate between each other. And that computer could be for anything. It could be to run the accounting system of a company, or it could be to share music. But in the case of a blockchain, the underlying information is the ledger that you showed that has accounts and balances.
Yeah.
And so and data, the balances are the balances of the cryptocurrency.
Yeah. Yeah. And if you want to get real abstract, you know, a cryptocurrency at its heart, of course, is a currency.
Yeah.
And so that's why I say cryptocurrency is a ghost, because that feature of it is, if we decide that it's valuable and start trading it around for things, then it becomes a currency.
Yeah.
But Ethereum and Ethereum Classic is, I think it's worth noting that the fact that it's a currency is, at least in my mind, almost incidental to what the protocol is about. Yeah, we have balances that go up and down, but we also use that, what is typically referred to as the currency, which can be and is a currency, Ether. You can also use that to run the smart contracts. And so in that way, I mean, if you removed 6 lines of code, we could have a blockchain that doesn't have the currency, doesn't have balances necessarily in the same way, it doesn't handle that in the same way, but you could still make use of the data, but it would work in a totally different way. Maybe you still need to have balances, so you know how much, how much credit you have to run programs, but but anyways,
I think I totally agree. It's a ghost, and it's a total abstraction, and it's not even a technical thing. It's not related to the technology. The fact that something is a currency, it could be a physical thing like grains of salt or gold or, I don't know, nuts. It's a unit that is inside the database, and it's being tracked and moved from account to account, and it's not strictly, it's more of an economic concept than strictly a technical concept. I think that it does have a relationship that is intrinsic to the technology, in the sense that because it has value, economic value, then the node operators want to be part of the network and run the node and participate, not because they get compensated somehow, especially the miners.
Yeah, especially even only the miners are compensated directly on the network. But there can be and are benefits to running your own node if you're not a miner. You may not be compensated in currency, but I think there's a case that you're compensated in risk management and risk. Right. So that's the big one, right? Because at the end of the day, that's sort of one of the key functions of these cryptocurrencies in general, is that, we're working towards something that's risk averse, and running your own node, participating in the network in the way that it's designed, allows you to harness that property.
The one that are not miners, they seek risk aversion, and they want to verify the truth of their balances and the state of their apps and things like that. So that's very important. Interesting concept. I would say that there's other node operators that also have like a secondary kind of income for compensation, not direct like the miners, but because they do some business outside of the blockchain, like an exchange or a block explorer that sells advertising because they have a lot of traffic, or they have a wallet and they make money somehow, and they provide the service of channeling transactions and stuff like that. So, exactly. Good. Thank you. The second, I don't know if you have anything else about this topic.
That's all I know.
Okay. That's all we know. Well, no, the second topic, the second level would be approaching Core Geth as a software. What is the difference between the protocol and the software? It's not
The, the protocol, I would say they're the rules, and the software is the expression of those rules. They're coming to life.
Good.
So
a protocol, the ETC protocol is, okay, everybody has the EVM. There's this set of opcodes that the EVM can run. We're going to use Solidity to write programs, and all the programs are going to be replicated everywhere. And when you receive a transaction written in a certain form, those are all rules, no? And then we're going to pay ETC to the miners when they send us the block, and when they send us the block, we send it to everybody. Those are just the rules, no? Whether it's implemented in what software or the other is a different concept.
Exactly. Yep. At its most basic, an example maybe for the beginners is if you and I decided to play a game, and we said every time that one of us says ping, the other one says pong, right? And then so that's the protocol, right? That's our game. Doesn't accomplish much, but those are the rules of the game. And then we can write software that is, whenever it hears a ping, it responds with a pong. And there's a protocol generally. And if you say something besides ping, you say, "Uh-oh, that's not part of the protocol." Throw an error. I don't know what to do or whatever. But yeah,
good. The third question is also difference between such and such is, okay, now we talk about Core Geth. Core Geth is called, everybody calls it a client, no? A software client in general, no? Or node client or software client. But blockchains are not so, or maybe are simple, and they're not strictly clients, no? There's a relationship where all the nodes are both clients and servers.
Yeah. On the network, sort of we've inherited that jargon from the server-client relationship, which is the paradigm of most of the internet, and so we just have sort of hacked ourselves into that jargon and just refer to these programs as clients, and are proud that there are no servers, because the whole point is there's no centralized server.
What is the paradigm of the client server? Because I started to read about software and technical things in the blockchain industry, so I don't know how do client servers work in the other world.
I think, like, just coming back to the internet analogy, we could say when you visit google.com, you're the client, and your browser, Safari, Chrome, Firefox, that's a client, and it's going to make a request to Google for whatever Google's got. And so there's typically, if you're looking at drawing a picture of it, you draw 10,000 clients, people just like you and me out there making requests, and then some headquarters somewhere with a very big computer serving all of those requests. And so there's your server and there's your client.
So in that kind of relationship between the software client, which is the browser, and the server, is like a fixed relationship. They always work the same way. This one requests and this one sends, and that's the only kind of relationship.
Typically, yeah, exactly. And the client's always expecting to get a response exactly from the server.
And in the blockchain industry, how has that changed?
Well, the networks, when we draw our picture of all these clients making requests to a server, maybe in the middle of the picture, the blockchains and these the decentralized networks that they're typically patterned on, that the protocols that they use are patterned on, remove that central issuing server, and so it just becomes a ring of clients who ask themselves for the state of the data.
So at any given time, any node in the blockchain can be a client or a server, depending on what the other nodes are asking for.
Exactly. Exactly.
And
Yeah.
what is the kind of data that or the information that they pass between each others, where one is a client, the other one is a server, and then the other one is a server and the other one is a client and stuff like that?
Yeah. Yeah. The Ethereum protocol is actually strikingly simple. So, you know, a couple of handfuls of request and response patterns. But the client will ask for and send block data. So like, hey, I got a latest block here. Anybody know about this one yet? And so you announce that to whoever you're connected to. And if you hear about that and you don't have that block, then you can process it. So they shuffle around block data. They do the same for transactions to manage a transaction pool so that miners have a view on which transactions are available to the network. And the other big one, important one, you got block data, transactions, and the other one would be peering. So that you can, and that's sort of one of the big differences in the client-client pattern versus the client-server pattern. When you have a client-server pattern, you always know who to ask for data. You just go to Google. As long as you're actually connected to Google, you can get the right answer. But the challenge with a decentralized network that you're never quite sure who's going to be on the network because anybody can be at any given point. And so managing those relationships and sharing information about peers is one of the other big parts of the protocols.
So in Ethereum Classic, there's the great majority of the nodes are Core Geth, and then there is a minority that are Hyperledger Besu nodes. That's another client software or software client in Ethereum Classic. And then there's one or two who are Aragon because they're being tested or something. Does this mean that, for example, if there is a Hyperledger Besu in the United States or Canada, and there's somebody running Core Geth in Russia or China, that they're talking to each other, even though there are different versions and different.
Yeah. Yeah. That's exactly it. That's exactly it. And I think, you know, to come back to the familiar internet analogy, it's sort of like, you know, the Besu becomes, let's say, Firefox over in, you know, somewhere in Russia or Canada or wherever. And then you got Safari or Chrome or, you know, Brave or whatever somewhere else. And so they can both handle the HTTP internet protocols, and they should behave pretty much the same way. But they're implemented by different companies and supported, and, you know, they're different pieces of software, but doing the same thing.
And to be able to identify and find each other, does each of them have like a list of what is the IP address of the others? If there's 600 nodes, do I have a list of the 600 nodes and I randomly talk to whoever I want, or do I have a smaller?
Yeah, that's exactly, and it's up to the client configuration, right? So your client, you can say, I want to only talk to 5 nodes ever at once, or you can say, hey, I want 1,000 max, you know, and give me whoever you got. And but yeah, that's basically it. Is that and for security reasons, they do also that random, like you said, that's right on, and it's important that there's an element of randomness in there too, because
that's interesting. I didn't know that.
Yeah.
So they randomly say they don't talk to the same one all the time. That's interesting.
Right. They'll maintain connections if they get a relationship with another client that's stable and is giving them good information and is a good peer. Then for the sake of efficiency, they'll definitely maintain that relationship. But yeah.
Sometimes they try others just for security.
Sometimes exactly.
Diversify.
Yeah. Strength and diversity. I
didn't know that security feature of the network. That's interesting. And bueno, let's go then closer to the nitty gritty. Core Geth is the software, the software client in ETC that has the most share of 500 or 600 nodes. It has more than 50% share. I think it's 70 or 80%. So a lot of people are running it. But Core Geth is not exclusive of Ethereum Classic. You told me when we spoke before that it's primarily used for Ethereum Classic, but it's really an EVM client, a software client or node software. And this means it can work in the EVM space in general. So can you tell me what is the EVM? What is an EVM blockchain, and how Core Geth can work in ETC and other blockchains?
Yeah, boy, that's a big one. The EVM that's the Ethereum virtual machine, and it's that virtual machine that makes the protocol special. I like to say if Bitcoin is a calculator,
Yeah.
then Ethereum's a computer.
Mm-hmm.
And it's that EVM that makes it the computer. What else? Yeah, maybe, yeah.
The EVM is the virtual machine that is replicated in all the nodes, it's what upgrades ETC to a computer because it has much more functionality,
Right.
etc. And Core Geth can be used for ETC, and it's today configurable to be run for other blockchains. If so, what other blockchains?
Yeah. The Core Geth has supported Ethereum for sure out of the box, along with the testnets and the testnets for Ethereum Classic.
Okay.
We've also supported MusicCoin in the past, and I don't have it in front of me, but there's a list of other networks that we've done too. And they come and go in the Core Geth code base as these other networks spin up and run, and then support for them is dropped if they drop off the map. We like to have the maintainers of whoever's trying to get their blockchain into Core Geth show up to help do the maintenance for that too. And so they've come and gone over the years.
If I'm a node operator and I want to run Core Geth, I download it and I turn it on for Ethereum, and it starts being a peer in the Ethereum network. Is that how it works? I can run it for the Ethereum network and it becomes a peer there?
Yeah. Yep.
And if I say, okay, now I want to redirect it to Ethereum Classic, I just switch and
Yep.
it starts downloaded the Ethereum Classic blockchain.
Yeah. Yep. Sweet. Exactly. Yep. Yep.
Okay.
And Ethereum Classic's EVM, like back to the Core Geth like pattern idea, is that I think it's a continuous theme for Core Geth that we want to be like working at this level of abstraction with the protocol that is accessible and extensible. And Ethereum Classic needs that because of its few differences with Ethereum. And so we have an EVM that is in all ways equivalent with the Ethereum EVM, except for an opcode that we left out, base fee, because Ethereum Classic didn't implement EIP 1559. Which is a change in the transactions and
and it's a virtual change in the monetary policy as well.
Right, and so it didn't make sense to include that opcode at ETC because we don't have such a thing as base fee. But the way Core Geth was set up, it even wanted to be like a sort of one of the things that came out of our articulated features and things is that we were able to support different configuration specifications as well. And so we could take a Besu configuration file and have Core Geth support that right out of the box, or the Ethereum configuration file. And the configuration is a big deal because the configuration for Ethereum Classic is not expressible in the way that Ethereum defines their configuration. So we had to make changes in order just to be able to say what we needed to say. And because of those changes that we made, we're very adaptable to configuration schemas.
Well, let's talk about these things, the unique things of Core Geth as an EVM client software, as a general EVM client software, but in particular the most popular one for ETC. So one of the most unique features that Core Geth has, that you told me before, is that it has articulated configurations, which is this that you're explaining, no?
Yeah.
What is articulated configuration?
For anybody besides a developer, I got to say it doesn't matter. Most people just want to turn it on and run it, and they will never see it and know about it, and that's fine.
Yeah.
But for a guy like me, whose job it is to write code for these specifications, EIPs and ECIPs, it's hair raising going through the code base, for example, upstream, and trying to figure out, there's these lines, these conditions in there that'll say like, well, if the fork is such and such, then do this and do this and do this and do this and do this. And all of those things that it's doing, sometimes they're related and tightly coupled, and sometimes they're totally different things, but they're all handled through the same switches. Which in my opinion makes for a pretty tricky testing situation, as well as an implementation, extensibility, readability, modifiability. And so we're right now in a position where every EIP gets its own flag, gets its own condition. And so that makes the code very clear. This is code for EIP 3520, right? It's not code for EIP 3520 and 3594 and 42 and blah, blah, blah.
Yeah.
And so, yeah.
So so it breaks down the hard forks or the upgrades into a feature by feature basis, isolating each feature, making it very modular, I guess, and very easy to select which ones you want and which ones you don't want. And I guess this is very important for Ethereum Classic in particular, because we want to not include some things and include others. So
exactly.
Modularize is important. And I guess also it must be important to use it for other networks, because you can say, okay, these 8 things are for that network, these other 5 things are for this other network, so you can turn on switches and turn them off. Yeah, which for developers is great, and but again, for most people, they'll never see it, and that's fine. Yeah. Well, now let's talk about 2 more things that are unique to Ethereum Classic. One is ETC hash and mess. That was more or less, both were like a response to 51% attack. Can you summarize what are ETC hash and mess? Yeah. So the original Ethereum proof of work algorithm, which is what your computer or GPU is going to be doing when it's doing the work, and the algorithm is called ETH hash or ET hash. It goes both ways there. And it's intended to be what's called a memory hard algorithm. And so it demands that the GPUs typically have some allocation of memory available to them, which restricts the kinds of hardware that you can use to do the work. And Ethereum Classic, differentially from Ethereum, while we shared that same proof of work algorithm for many years, Ethereum Classic finally changed the algorithm in a way that reduces the demand on memory for those GPUs. So what that did practically for Ethereum Classic was, over the years, actually the requirements for memory had gone up. That's part of the algorithm, is that over time you have to have more and more and more and more memory. So that means that over time you get a subset and a subset and a subset and a subset of GPU and hardware that's able to handle those demands or meet those demands. And so by reducing the amount of memory, you also
open the playing field, so to speak, so that GPUs that don't have 6 or 8 gigabytes of memory can still participate. And so that's one of the things that Core Geth has had to implement for its protocol that upstream Go Ethereum has not had to implement, because they never changed that.
Yeah, good.
Yeah.
Bueno, we have very little time left because Zoom is limiting my time for recording. So bueno, we can talk about MES, OpenRPC, and the Parity style tracing logs in another interview. Thank you so much, Isaac, for your time.
Oh, thank you, Donald.
We can do this maybe in a couple of weeks or in a month or so.